8.4 Proportionality Theorems. Essential question: what proportionality relationship exists in a triangle intersected by an angle bisector or a line parallel to one of its sides? Let's take a look at the first theorem, which is called the triangle proportionality theorem, which states that if you have a line that's parallel to a side of a triangle, then this line does some dividing. It divides it into two pieces. I'll call this an upper one because it's close to the angle. I'll call this a lower one. And this whole side has been cut into an upper 2 over the lower 2. And what it's saying is that this ratio of RT over TQ is the same as the ratio of this upper 2, which is RU, all over SU. And that only happens because the lines are parallel. The converse will say that if this relationship is true, if this ratio to this ratio are equal, then you can conclude that the lines are parallel. Let's go ahead and work on a problem. All right, so I have this line that's parallel to the third side. So this creates an upper 1 and a lower 1, an upper 2, because they've been divided, the side's been divided into two pieces, and a lower 2. All right, so what I can say is RQ, that upper, is to 9 as the upper is to 6. And I'm going to go ahead and do some reducing, 2 over 3. And I can see that if I take this number 3 and I times it by 3, I'll get the number 9, so I'll times the numerator by 3, and I will get RQ is equal to 6. The other way you can do this is you can just cross multiply from the very beginning. So you can just do 6 times RQ is equal to 36, then divide both sides by 6, and then you're going to get 6. Notice that I get the same answer again. Now, what I don't want you to think is this. We get RQ, which is the upper, over QU, which is a lower. Upper is RS over the lower, which is ST. And this is absolutely not equal to QS over UT. I want you to notice that this is not part of the division that's being made by the lines. In fact, QS is the side of the smaller, and this is the side of the larger triangle. So this has nothing to do with how these got cut. This is a big mistake students make, and I want to help you avoid that. Okay, now your turn. See if you can find YZ. Stop the screencast, set up the problem, and solve. Now here's the answer. Again, I used that upper and lower, substituted the numbers, and then found the answer. I also rounded to get a feel for what 315 over 11 is. We'd like to now decide whether these lines are parallel if we know these divisions here, how they were divided. I do upper, which is 27 over 33, and upper, which is 44 over 25. I reduce this to 9 over 11. 3 goes into there, 9. 3 goes into 11. And I can see these ratios are not equal to each other. If the ratios are not equal to each other, then this can't possibly be parallel, so they're not parallel. Your turn. Go ahead and see if you can determine whether PQ is parallel to QR. Stop the screencast. Here's the answer. I went ahead and found the upper to the lower. Again, upper is just what I choose that's close to the angle. And I found that the ratios are exactly the same. When the ratios are exactly the same, I know the lines are parallel by the converse of the triangle proportionality theorem. Our next theorem is about three parallel line theorem, and the three parallel line theorem says that three parallel lines will divide a side into parts again, and I can consider this an upper and a lower, and which one is upper, which one's lower, it doesn't really matter on the three parallel line theorem. Just make a decision and do the same thing on the other side. So if I consider this the upper, then this will be the upper 2, and this will be the lower 2. So that's how I remember the theorem instead of with letters. Okay, let's go ahead and see if we can do this problem. I understand that this is I'm going to let this be my upper, and this is my lower, and then this is going to be my upper 2 and my lower 2, and I'm going to try to figure out GH. After I figure out GH, then I'll try to figure out HF. Okay, so here I go. upper 1, which is 120, all over lower, which is GH, equals upper, which is 150, all over 300. And I can already see this is a 1-to-2 ratio, so this allows me to say that GH is equal double the amount, which is 240. Now that's going to let me find HF. HF will be FG, which is 120, plus GH, which is 240, and so the answer is 360. Now there is another way to work this because proportions are very open to a lot of ways to set them up. And what you could do is you could set up upper to whole. Actually, this represents the whole, those two added up, and we can have a whole on this side. So I'm going to do upper to whole, the whole length equals upper 2 to the whole length there. Now upper 1 is 120, and the whole here is what I'm really looking for, HF. And then upper is 150, and then the whole is these two added together, which is 450. Now that tells me this is a 1-to-3 ratio. So I know that HP is 3 times as big, which is 360, and that's exactly the way I got it this way. So there's more than one way to do the problem. Your turn. Go ahead and find these lengths. Stop the screencast. Now here are the answers. Here's our last theorem. It's a triangle angle bisector theorem, and it says that when you have an angle bisector, it divides this into parts. So I'll call this part 1 and part 2, and this ratio between part 1 and part 2 is the same as the ratio of the sides, side 1 and side 2, and that's really how I remember this theorem. Let's go ahead and do this problem. This is part 1, and this is part 2. This is side 1, and this is side 2. So I have part 1 all over part 2 has a ratio, and that's the same as side 1 over side 2. Now part 1 right here doesn't have a number, but I know it's the leftover from 15. So I'm going to say 15 minus x, and then part 2 is x, equals side 1 is 7, and side 2 is 13. Now a lot of students forget to distribute, and this is a big mistake they make in their algebra. And 13 times 15 is 195, minus 13x is equal to 7x. So 195 is equal to 20x, and x is equal to 9.75. And we were asked to find RS, which is x. So we have found this length. Okay, now it's your turn to find the values of x and determine y for number 6. Stop the screencast and see what you can do. And here's the answer. Again, I set it up with part 1, part 2, side 1, side 2, and I am able to find these answers. It looks like I don't have the answer for y, and y will be equal to 4 root 2, and that's because this is in a 1-to-1 ratio, so these lengths have to be the same as well.